Good morning.
Good morning.
So what we studied in the last class? Which topic? Which topic? Anyone?
I'm electric circuit.
Electric circuit, and one more topic. One effect of electricity that we discussed in the previous class. Which effect of electricity?
I'm heating.
Magnetic. The last class we discussed the magnetic effect of electricity, and before that we already discussed this heating effect of electricity. Is it?
Yes, ma'am.
So Dennis Stanley.
Yes, ma'am.
Say any example for heating effect of electricity. Any
Ma'am.
example?
Ma'am, heating of the filament.
Say
Ma'am, heating of the filament in the bulb.
bulb. Okay. So because of the heating effect of electricity, the bulb glows. Is it?
Yes, ma'am.
Okay. Then Asra Fatima. Asra Fatima. Say any example for this magnetic effect of electricity. Any observation? What we discussed in the last class. This topic. What we discussed about this magnetic effect? I can't hear you. What we discussed in the last class about magnetic effect? When we connect a magnetic needle to an electric circuit, what we observe? What is observation? Anyone say? Yes, say.
And
Asra?
changes the direction of the needle.
Direction of needle. There is a deflection in the needle, is it? So, if the liquid contact electricity, at that time there is one deflection. And if the circuit doesn't contact electricity, is there any deflection?
No, ma'am.
Is there any? No. So we already discussed two effects of electricity, that is heating effect and magnetic effects of electricity. So what's the name of the chapter? What's the name of the chapter? Chapter name?
Chemical effects of electric
Chemical effects of electricity. So next we have to discuss about this chemical effects of electricity. Okay.
Yes, ma'am.
Okay, so the next topic is chemical effects of electricity. What is meant by this chemical? What is meant by chemical change? What is meant by chemical change? So what will happen when heating effect? Filament is heated. The filament of the bulb heated. What we observe? The bulb glows. The bulb glows. Is it? And then when there is a deflection, there is passage of electricity, the magnetic needle deflects. So that is magnetic effect. So here it is chemical effect. So this water, what about this water? Is it a conductor or an insulator? Water. Water is the conductor or an insulator? Conductor, is it? So this water conducts electricity. So is any change there in this water when it passes electricity? Can you observe any change in this liquid? If we take water as an example, when we pass electricity, the water is a conductor. So because of that, it conducts electricity. So at the time when it passes electricity, is there any change in that water? Is there any change? There is one change that we have to study in this topic, chemical effect of electricity. For that, the scientist William Nicholson do one experiment. This experiment is like this. So he took one container, inside that it is water. Okay. For this experiment, we take the liquid as water. So this water conducts electricity or not? Is the water conduct electricity? Is this water conduct? Yes, yes. This water conduct electricity. So William Nicholson take water as a liquid and Two electrical. Is this an electric circuit? Is this diagram is an electric circuit?
Yes, ma'am.
It contains one liquid, electrical wire, and what is this?
Battery.
Battery. So two cells are there. So this is a battery. Is connected to a battery. And here at the end of this electric wire, two metal rods are there. Can you see this? Two carbon rods. Huh? Can you see this one? Two metal rods, two carbon rods are here now. Is it?
Yes,
Okay. So what are the two sides of a battery? Which are the two sides of a battery?
Positive and
Ah.
negative.
So how will you understand the two sides? How will we understand from this simple? How will we
ma'am.
understand?
Ma'am,
Bigger
long-
one positive and smaller one negative.
The longer one it is positive and the smaller one it is
Negative.
negative side. So here it is the positive side of the battery and here is the negative side of the battery. Okay, clear? And this
Yes, ma'am.
one metal rod. So two metal rods are here, two same metal rods, carbon rods. Here also carbon rod. And this metal rod that is connected to the positive side of the battery. Okay, the metal rod that is connected to positive side of the battery. This is known as anode. Okay, clear? These are two electrodes. Two electrodes are the two carbon electrodes are there. That metal rods are called. Both the metal rods are called electrode. Okay, these metal rods are called electrode, and the metal rod which is connected to positive side of the battery is known as anode. Okay, and then again the metal rod that is connected to negative side of the battery is known as cathode. Okay, clear? So two electrodes are there. So he takes one container, contains some water, and it is connected to an electric circuit. And two metal rods are dipped inside this water. So two metal rods that are carbon rods. For the experiment, we took the carbon rods are electrodes, and the metal rod which is connected to positive side of the battery is known as anode, and the metal rod which is connected to negative side of the battery is known as cathode. Okay, so what is the charge of this anode? Is connected to positive side. So what is the charge of the anode? Same. What is the charge? What is the charge? Positive charge. So anode, positive charge. So anode, positive. And what about this cathode? What is the charge of this cathode?
Negative charge.
Negative. So anode is positively charged and the cathode is negatively charged. Okay. So in order to understand whether there any change in this water when it pass electricity, whether there any change in this water, William Nicholson do one experiment for this. He took one container. It contains the water as the liquid, and it connected to an electric circuit, and these electric wires are connected to two metal rods. The two metal rods are dipped inside the water. For the experiment, we took carbon rods or electrodes, and this electrode that is connected to electrode or metal rod that is connected to positive side of the battery is known as anode, and the metal rod that is connected to negative side of the battery is known as cathode. This much clear? Much clear?
Yes, ma'am.
And then what's the liquid inside this container? Which liquid? Which liquid?
Water.
Water. So what is the formula for water? Samuel Benu. What is the formula? Chemical formula for water? You know? What's the chemical formula for water? Anyone? Chemical for H2O. Okay. H2O. So which are the components in this water? Two components are there now in this water. Which are the two components? Two elements. Hydrogen and
Oxygen.
Oxygen. Okay, hydrogen and oxygen. Actually, this William Nicholson proves that when we pass electricity through this water, it breaks into two components, that is hydrogen and
Oxygen.
oxygen. So when we pass electricity through this water breaks into hydrogen and oxygen. So which are the two components present in water? Hydrogen and oxygen. So when we pass electricity through this water breaks into hydrogen and oxygen. Clear? Then how do you prove this? That we have to no need to study this one if you understand what to observe from this experiment. So actually this hydrogen breaks to form hydrogen and oxygen. So these are two components of hydrogen and oxygen. So charge of hydrogen is positive. Okay. When any liquid or any salt breaks, it breaks into two components. One is positively charged, another one is, if one is positive charge, another one is which charge?
Negative.
Negative charge. So the same in the case of water also, when water breaks, when we pass electricity, the water breaks into two components. This hydrogen is positive charge and oxygen which charge? Negative charge. Clear? So here anode which charge? Charge of anode?
Positive.
Anode positive charge and charge of cathode?
Negative.
Negative charge. So anode positively charged, cathode negatively charged. The same next point, when water breaks, it breaks into two components, hydrogen and oxygen. Hydrogen is in which charge? Positive charge. Oxygen is in
Negative.
negative charge. And one more thing that you study in physics, same charges repel and opposite charges attract. Is it? Same charges repel and opposite charges attract. Okay. Then my question, anode is positively charged and cathode is negatively charged. Here also hydrogen is positively charged, oxygen is negatively charged. So which component move towards anode? Which component move towards anode? Which one? Hydrogen or oxygen? Which component moves?
Oxygen.
Oxygen. Why? Why?
Because oxygen.
Hydrogen positive, oxygen. Say. Because
Unlike charges attract each other.
unlike charges attract. That means anode is positively charged. So which component moves towards this anode?
Oxygen.
Negatively charged component. So negative to positive. So opposite charges will be an attraction. So oxygen moves towards positive charge anode. And what about this hydrogen? Charge of hydrogen is positive. So it moves towards
Cathode.
cathode. Is it clear?
Yes,
So in this electrode, two charges are there. Anode positively charged, cathode negatively charged. And again, when water breaks, there are also two components, hydrogen and oxygen. Hydrogen is positively charged and oxygen is negatively charged. And what we observe is at the passage, at the time of passage of electricity, this hydrogen moves towards cathode. That means positively charged hydrogen moves towards negatively charged cathode, and this negatively charged oxygen moves towards positively charged anode. And you observe in this experiment that when we pass electricity through this water, the bubbles of oxygen in which electrode? Bubbles of oxygen in anode. Clear? Why the bubbles of oxygen we can see near the anode? What's the reason?
Because it attracts.
Because oxygen is in negatively charged, is it? Oxygen negative charge, so it moves towards the positively charged electrode. Which is the positively charged electrode?
Anode.
Anode. Okay, clear? So anode positive charge, oxygen negative charge. And again, what about this hydrogen? Where we can see these bubbles of hydrogen near this cathode, because this hydrogen is in which charge? Hydrogen which charge? Hydrogen,
Negative.
hydrogen which charge?
Positive. Positive.
Positive. So hydrogen positive charge, so it moves towards this cathode, because the cathode is in which charge? Cathode
Negative.
negative charge. Is it clear?
Yes,
Is this
ma'am.
clear? Then Alan Jolie.
Yes, ma'am.
The electrode which is connected to positive side of the battery is known as the electrode which is connected to positive side of the battery. That electrode is known as the name. Two electrodes are there, anode, cathode. So which electrode is connected to positive side of the battery? Alan. Neha Mary. Which electrode is connected to positive side of the battery?
Anode.
Anode. Okay. Very good. It is anode. And again, Naveen PS.
Yes, ma'am.
Which electrode is connected to negative side of the battery? Cat. Yes, cathode. So cathode is connected to negative side of the battery, and anode is connected to positive side of the battery. And for the breaking of this H2O, Advait, which are the two components of water? Which are the two components of water?
Yes, ma'am.
Which are the two components of water? Water breaks into foam. Which are the two components? Which are the elements present in this water? Afrain. Which are the two components in water?
Hydrogen and oxygen.
Hydrogen and oxygen. So what is the charge of this hydrogen?
Positive.
Positive. And what is the charge of this oxygen?
Negative.
Negative. Advait, is it clear now? Huh? Is it
Yes,
clear?
yes, ma'am. Yes, ma'am.
Okay. Then Dion Xavier. Dion.
Yes, ma'am.
This hydrogen moves towards which electrode? Hydrogen. Which electrode? Hydrogen moves towards which electrode? What is the charge of hydrogen? What is the charge of hydrogen? Huh?
Ma'am, can you repeat?
What is the charge of hydrogen? Charge of hydrogen, positive charge. So it moves towards which electrode? Cathode or anode?
Anode.
Cathode or anode?
Anode.
Say, why it is moved towards anode? What is the charge of hydrogen?
Positive.
Positive. What is the charge of anode?
Positive.
Positive. You can move towards anode.
Hydrogen.
Same charge. Hydrogen positive charge, anode positive charge. Same charges attract or repel.
Repel.
Repel. These two same charges now. Hydrogen positive charge, anode positive charge. So there is one repulsion. So hydrogen move towards which electrode?
Cathode.
Cathode. Okay, clear? Okay. So this hydrogen moves towards cathode, and the oxygen, what about this oxygen, Nihal?
Yes, ma'am.
This oxygen moves towards which electrode?
Anode.
Why?
Because opposite charge is attractive.
The unlike charges attract, so this negatively charged oxygen move towards positively charged anode. Okay. So from this experiment, this William Nicholson proves that when electrodes were immersed in water and a current was passed, what we can observe? Bubbles of oxygen and hydrogen were produced. Clear?
Yes, ma'am.
Then where we can observe this oxygen? Where we can observe this oxygen bubbles? At anode. Okay. Then where we can observe this hydrogen?
Cathode.
Cathode. So from this experiment he proves that passage of an electric current through a conducting solution causes chemical reaction. Which type of reaction? Chemical reaction. What's the chemical? What is meant by chemical? One substance entirely changes into another one. What is the state of this water? Is it a gas, solid gas or a liquid? Water. Water is a liquid. And the component is hydrogen. What is the state of hydrogen? Solid, liquid or a gas? Hydrogen?
Yes.
Gas. And what about this oxygen? Gas. Okay. So the hydrogen and oxygen are gases. Water is a liquid. So when we pass electricity through this liquid, this changes into two gases, is it? So this type of changes are called chemical reactions. So the same passage of an electric current through a conducting solution causes which type of reaction? Which type of reaction? Chemical reaction. So this is known as chemical effects of electricity. Is it clear?
Yes, ma'am.
Is it clear? So what we can observe? Chemical reaction means bubbles of a gas may be produced on the electrode. Is it? So in the case of water, which are the bubbles produced at the electrode? Which are the bubbles? In the case of water, when we pass electricity through this water, which are the bubbles? Hydrogen bubbles and oxygen bubbles. Then in some cases there is a change of color of solution may occur. Okay, so there are two changes we can observe by the passage of electricity through any liquid. The two changes, the two chemical reactions. Bubbles of a gas may be produced on the electrodes. Change of color of solution may occur. Clear? Nihal?
Yes, ma'am.
Which are the two changes we can observe by the passage of electricity through conducting solution? Two observations are there. Which are two observations?
Change in color,
Change in color of the solution.
bubbles.
Bubbles where? There we can observe these bubbles. There we can
Electrodes.
observe electrodes. These are the two types of electrodes. These are two types of electrodes. Diya is there. Which are the two electrodes? Name two electrodes. So which are the two electrodes?
Ma'am, can I say
Yes.
anode and cathode?
Anode and cathode. So we can observe the bubbles of a gas on the electrodes. Either it is in anode or it is in cathode. In the case of water, where we can, which bubble we can observe in anode? Which bubble? Hydrogen or oxygen? Anode. Oxygen bubbles. Okay. Anode, oxygen, and this cathode is hydrogen bubble. So these are the two observations. Bubbles of a gas may be produced on the electrode. Otherwise, change of color of solution may occur. So this is known as chemical effects of electricity. Okay.
Yes, ma'am.
Okay. This. So how many are present? 33, 37. Total 37, no? So one more topic in this chapter, that is electroplating.
Ma'am.
Oh, yes.
Students present.
Okay, Aris. Okay. Okay. That okay. So one more topic in this chapter, that is electroplating. So that we can discuss in the next class. Priyanna is there. Nigel John. Nigel.
Ma'am.
Okay, so not clear. So which are the two electrodes? Which are the two electrodes?
Anode and cathode.
Okay. Faisal Sheikh.
Yes,
Faisal
ma'am.
Sheikh. Which electrode is connected to positive side of the battery?
Sorry.
Which electrode is connected to positive side of the battery? Anode or cathode?
Cathode.
Positive side. Which electrode is? Positive side it is?
Yeah, I think so.
Cathode.
Yeah.
Okay. Alan Jolie. Which electrode is connected to positive side of the battery? Anode or cathode?
Anode.
Anode. Faisal, are you there?
Yes, ma'am.
The
Anode.
anode. So the electrode is connected to positive side of the battery is anode, and which is connected to negative side of the battery is
Cathode.
cathode. Okay. Then Saranya is there? Saranya. Joel. This class Joel? No. Shivakrishna. No. Samuel Benu.
Yes, ma'am.
Which are the two components of water?
Hydrogen and oxygen.
Oxygen. Okay. Avnita.
Yes, ma'am.
When we pass electricity, where we can observe these hydrogen bubbles?
Hydrogen cathode and oxygen in anode.
Why we can observe these oxygen bubbles in anode?
Because unlike charges attract each other.
So what's the charge of this oxygen?
Oxygen is negative,
And what about the charge of this hydrogen?
positive.
Positively charged. And Aryan Sujesh. Aryan.
Yes.
Say any example for heating effect of electricity. Heating effect. Any example? Heating effect of electricity. Any example?
Ma'am, light bulb.
Bulb glows. Why the bulb glows? What's the reason?
Because the filament gets heated,
Hmm.
so it produces light and heat.
Okay, the filament heated because of this heat, it produces light. And Neha Mary,
Yes, ma'am.
if a solution conducts electricity, what we can observe in the magnetic needle? What observation?
Change and needle.
What we can call for the change? That movement, one word is there for that movement. Anyone? Movement of deflection. There is one deflection. The solution conduct electricity. There is one deflection in the needle. Otherwise, there is no deflection. Clear?
Yes, ma'am.
So these are the three effects of electricity: heating effect, magnetic effect, and the last one, chemical effects of electricity. Clear?
Yes, ma'am.
Okay. So can you wind up today's class?
Yes, ma'am.
Okay. Thank